Right, so in this video, we're going to count the numbers of atoms in a sample of SiO2. Now, SiO2 is the formula for the mineral quartz. And to calculate the total number of molecules of quartz or the individual numbers of atoms and oxygen and silica, we have to start with the periodic chart and get the atomic weights of these materials. And so for silicon, the atomic weight is 28.0855. That's an 8. That's in grams per mole. And if you look at your periodic chart, you'll see that oxygen has an atomic weight of 15.9994 grams per mole. And that is so close to 16, I think, at least for writing purposes, we're just going to round it off to that. Now, if we want the the molecular weight of SiO2, we have to add the weight of one silicon atom, but there are 2 oxygen atoms here. So we're going to have to multiply this by 2. And so when we multiply that by 2, we get 32. Just round that off to 16 then. 16 times 2 will give us 32. So we'll have to add 32 and 28.0855. And when we add those 2 things together, then for the molecular weight of SiO2, we get about 60.05 grams per mole. So that means if we weigh out 60.05 grams of SiO2, then we would have 1 mole of silicon. Right? But let's say instead of 60 grams, we only have 10 grams. You rummage around the garage and all you can find is 10 grams of quartz. So we have 10 grams of SiO2. So what we're going to do is convert that using this conversion value. Right? We're going to use this value, 60.05 grams per mole, to convert 10 grams of silica into the number of molecules of silica. So we want grams to cancel. So grams is down here. We want it up to cancel this fellow up here with moles on top. So if this is grams per mole, and this is grams per 1 mole, when we don't write a number here, it always means that we've got a number 1 at the bottom. So we're just going to invert it. So we've got 60.05 grams, and that is per 1 mole. And so when we do that multiplication, we find out that we have 0.1665 moles of SiO2. Now, how many actual molecules do we have? Well, this is where Avogadro's number comes in. Avogadro's number is 6.022 times 10 to the 23. Now, it's a unitless number. It has no units. So just like a dozen is 12, then a mole is this very large number, which is handy for counting very small things. So what we're going to do is we're going to take Avogadro's number and simply multiply it by the number of moles that we have, right? And it's kind of like saying this. If I had, let's say, 3 dozen eggs, right? And there are 12 per dozen, then multiplying those would give me 36 eggs. So it's really just kind of the same kind of calculation here, except we're interested in the numbers of atoms rather than the numbers of eggs. So when we multiply this out, 6.022 times 10 to the 23 is going to equal this down here. It is about 1.0028 times 10 to the 23. So that would be the number of molecules of SiO2 in a quartz sample that weighs 10 grams. Right? So that's the total number of molecules of SiO2. What about the total number of atoms? Let's erase the chalkboard here, and we'll rewrite the number that we got earlier, 1.0028 times 10 to the 23, or the number of molecules of SiO2. Every molecule has one atom of silicon, so we must also have 1.0028 times 10 to the 23 silicon atoms. There are twice the number of oxygens, so the number of oxygens would be 2 times this number, 1.0028 times 10 to the 23. So that would be, well, we could really, let's just ignore this is really the 0.0028 part. We now have 2 times 10 to the 23 oxygen atoms. And in total, we would have, if we add these two things together, if we add up the total number of atoms, we would have 3 times 10 to the 23. I'm just dropping off the last few digits in the decimal place. So 3 times 10 to the 23 total atoms in 10 grams of SiO2. So that's the total number of atoms, right? So a third of those atoms, one out of every 3 atoms is silica. So we would have 1 times 10 to the 23. 2 out of every 3 atoms is oxygen. So 2 times 10 to the 23 oxygen atoms. The total number of atoms is this. And then when we combine those, that would give us about 1 times 10 to the 23 molecules of SiO2.